Okay, we should be live now. Looks like the levels are tracking. Let me just make sure my audio is all going to the right place. Okay, I'm just gonna give it a minute or two while I pull up a couple things. Since I made a tweet about how I would be starting 15 minutes late, and there's still a couple minutes. With that, I'll use that time to pull some stuff up off screen just to make sure I'm a bit more ready. Hope everybody is doing well. If you're watching this on replay, find a way to let me know. So we're gonna do a new Google Doc, and we're off screen right now if anyone is watching. Okay, so let's do a quick drink of water, then we'll do an intro, get a timer going, and we'll get started. I have water in that Mountain Dew can. Okie dokie. So, oh yeah, let me put a timer up there too. Alright, welcome everybody. I'm Liz. This is Liz Does It. This is the third of ultimately 4 live streams in doing live coding in R, developing signals models for the Numerai Signals Tournament, or a model. This is a project that was funded by Numerai's Council of Elders, so a special thank you to all of them, and thank you to anyone watching this live or catching it on the replay later on Twitch or on YouTube. Just a quick heads up that nothing here is investment advice. I'm just going to be analyzing data and setting up pipelines for analyzing data and making predictions. I do not constitute an investment advisor. I'm not an investment advisor. You need to do your own due diligence, take your own risks with your own responsibility. I encourage open discussion, exploring, and trying to learn a lot, but ultimately, I'm not giving investment advice here or ever. With that out of the way, let's get started. I need to pull up real quick. I need to pull up my accessibility software so I can use my switch controllers. Let's just refresh that real quick. Excellent. Okay. Great. Okay. So, I'll switch webcams. Oh, and we might get to do some whiteboard work, because I cleaned the whiteboard and we'll be thinking about stuff, so that might happen, which would be exciting. We'll move over here. Let's start a Pomodoro. And let's take a look at the notes from last time, and then we'll make a note file for this time. So we had some pretty light and abstract notes. Last time we wanted to turn my keyboard on. We wanted to load the Yahoo data, and we did that. We wanted to examine it, sure. And we wanted to construct indicators or predictors. We didn't do that so much, but that's all right. We did think about it and talk about it some. My USB hub got just a little bit disconnected there, so just fixing that. Excellent. So, let's make a new document. This will be called. I'm not sure if I moved the last one to the folder we want it in, but that's okay. Signals, development. I feel like these streams have been going really well, although the viewership has been very low, unfortunately. I feel like I've been really productive, and I've been able to accomplish a lot of my goals efficiently. So I'm really happy about that, because that plays in really well with my whole idea for Liz Does It in general, which is podcasts and videos like Twitch or YouTube or whatever, sort of documenting me working through a project from planning to, delivery or finishing and review, so that I can reflect on that and improve my processes, and anyone who might enjoy that content would get to enjoy it or maybe learn something from it. If anyone is watching, feel free, please say hi in the Twitch chat. I'm on Twitter and on the Rocket chat as well, but I'm paying the most attention to the Twitch chat. So, being the third of 4 sessions, I think we want to start thinking about like the finish line here. So like let's list out like deliverables. So deliverables that I want to conclude at the end of this streaming or in a brief video following would be a suite of scripts that allow analysis, or that set up rather. So a lot of this is going to have to be carried out by the user themselves, but I'd like to provide a skeleton for this. A set up, so we want to have a suite of scripts that set up data collection, analysis, model training, structure, or just say model training, that's included there. Model training, testing, and prediction for the numeri signals tournament. So within that, maybe we'll explore that a little bit more in a moment, but I also want to, and this will probably be a follow-up. And so deliverables doesn't necessarily mean like deliverable, like it's just goals for the end of the task. Let's just change that to goals. I like that word better. The more direct language, the less business lingo, the better. So that suite of scripts is one goal. A walkthrough, likely video and short, of the script output of the set of streams. And that suite, like, we've already developed a lot of that. I think just like cleaning it up some is going to be part of it. As part of Liz Does It, so I'll note that up front, because this is a goal for me rather than for the Council of Elders. Project review. And I think this is going to play into what we work on this time and next time. I think a lot of this session is going to be sort of defining a lot of small tasks that we want to do before this is all wrapped up, and following through on some of it. And another big chunk, I think, will be trying to actually train some models. We'll jump into R shortly, but this is an important part of software development and predictive script development, at least with how I do it. So within that suite of scripts, so we'll say the Yahoo scraping is one of them. We'll say data handling, and that's where like analysis can come in. And you know, some of these we might get briefly, or we might skip over them, but gonna do our best to get everything. We also want to do model training and testing. Let's say database updating, I think, is going to be important. So, like, you know, we already have a database, no need to like continually re-download the whole thing when we already have more than 10 years, you know, going on 20 years of data. We just need the stuff that's not already in the database since the last time we downloaded it, in order to, and even like we only need maybe not even all that, but like, you know, we want to keep the database whole, so a database updating script would be good too, I think. So a prediction file as well. So ultimately 5 scripts should do it. I think that's pretty good. We'll add or adjust as needed as we go. So we want to do a walkthrough video of the script output. I feel like at the moment it's pretty self-explanatory, so I don't know that I need to really expand on this. For the project review, I just want to include some elements that I might want in there, which could be like, how did it go? And we'll break that down into overall, planning, execution. And this is going to be like, I'm going to do this outside of the 4 contracted streams, since it's a part of my personal project. I'll try to get just that good stuff on stream as much as possible. So execution is a factor, and we'll include review as well there, just to be super meta. So that there's a fire truck going by. That was the question of like, how did it go? Um, let's say, and that can include like thoughts of like, was it a success? Was it not? Did it go faster, slower than I expected? It's kind of like I'm at the beginning of doing the Liz Does It project, so I'm just kind of seeing what comes out of the ether on that. And that is not to be confused with Ethereum, the cryptocurrency. Other than how did it go, I think a good question is what stuck out to me, and what might I change if I repeated something similar. In the future, and let's say anything else. I think that's a pretty good guideline. I might break into Xmind today as well. Some board work. We'll see if we get there. So what do we want to do today that's like not really necessarily covered up there? I think, well, it is covered up there, but I think we want to start with well, let's go through up here and add some asterisks for parts of the project that are basically or are actually done already. So Yahoo scraping, I think that one is basically done. Maybe a little cleanup, maybe not. Data handling probably is basically done, but I'll put that in parentheses in case we end up with way extra time. Doing some data handling and analysis would be a good thing to spend some extra time on. Model training and testing, I think this is where we're going to basically start today. Database updating, that's something we need to do too, as well as prediction. So we'll copy these. Oh, well, we don't need to copy them, we can just start on them. So let's, oh no, we will copy them because these are like goals for like cleaning up. Like we're gonna look at the code, and this will be on the 4th session. Which of course is the next session, but we're thinking about the goals because that's our next and last long live stream as part of this whole project, which is pretty exciting. I think it's gone really well. It would have been cool to have wider viewership, but honestly I didn't expect a whole lot of viewership in this format. What I expect and expected to contribute through this is a bit of a code base in R for people who want to use signals. There are a number of modelers in the classic tournament who use R or might prefer R, and that might be a stumbling block for them to get involved with signals. So I'm trying to help reduce the difficulty rating of that stumbling block for R users who might want to get involved with signals. And maybe some R user outside of the Numerai community entirely might benefit from it as well. So yeah, here we go. So I also think that doing this on stream, I've been way more efficient than I would have been if I weren't on stream. So I think that's providing a good value. Let's label this 3rd session today. Starting with model training and testing, so we're gonna have to reload the data, which I believe we saved. Wow. Hurt myself a little bit. I believe we saved it last time. So that should be not too hard. We need to decide inputs to our machine learning algorithm. We need to decide on the target. That's kind of basically set already. We need to decide which ML algorithm to implement. I like trees, but we might use something else. I think since the data is pretty huge, so like we set up, like we got like approximately the first 3 years of data, and then we skip about a year, and then we have another 3 years, and so that first and second data set are training and testing, sort of like initially. So like I think that's a good place for us to evaluate some algorithms and decide like the overall training structure, because we might be able to get some of that to crank in a reasonable time period on camera. Although it is like 1 million rows, I think, per data set that I just mentioned, and that's just like 3-year chunks. So like sort of my goal is like to do some testing here, or get an idea of how intensive it is, so we can have a goal of like, all right, we're going to train a model, and model storage is going to be another thing, and model loading. So like we're going to train a model based on those first 3 years, test it on the second 3 years, and develop a plan based on that about training that I'll do off camera later. So I'll do some training off camera later, and that will inform our final model, and we'll want to make a prediction. I should add that. Let me add that as a goal for 4th session. And then I'll move the 4th session down, because we're in the 3rd session. Let's keep that top of mind. Alright, so under model training, we have load the data, decide the inputs to the algorithm, decide the target, decide which ML algorithm to implement. We want to develop the overall training structure. We want to develop model storage. So, you don't want to have to train it every time. That would be unnecessary and even wasteful as far as time and electricity. If you can just reload it, unless you really want it to be up to date based on a week of new information each time, which I tend to think is probably not really necessary. And we're gonna go with like simple stuff, because we're optimizing for like the goals with all of this is that somebody who has a laptop ideally will be able to pull this off with just their laptop without having to rent a supercomputer on AWS and without having to buy data. And you know, that may or may not be like good. The model might not be great. That's okay. We're not trying to, like, we hope to have a great model come out of this, but more so the goal is the structure, the blueprint, the skeleton that we're developing. So we've got a few minutes left on our timer here. Let's bring up R. Make sure. Okay. We'll bring up R and try to start loading data. Then we'll take a break. My partner is heading to work soon, so I'd like to go say goodbye to them. I got some new tattoos yesterday. On my... They're pretty painful. If I'm being honest. Alright, so we'll make a new file for Signals Twitch 16. But let's take a look at the last one as well, so we can start loading our old data back up. So we have train 20, test 20, and train volume 20, test volume 20. I think we'll probably use like adjusted price and volume as inputs. We'll go real simple. Maybe just 2 inputs, or maybe we'll have some lagged predictors there. Ultimately, if somebody's watching this and is trying to build their own stuff, you're going to want to include like fundamental data. You're going to want to try to get insights from elsewhere. You think about it, everybody's got price data, so like you want to get as much juice out of that as you can, but there's a lot of question among people who are really knowledgeable about the econometrics and the finance, that like the price data alone is not really good enough to get an edge. I haven't confirmed that, so we'll see. But it's worth knowing that that's kind of the general opinion. Like, it's a little bleak. You might want to find ways to get that fundamental data, and especially if you can develop like unique stuff. Let's load our dates thing. We'll set our file name, and so we'll want to copy these over, and then we'll set some file names for the stuff we're going to start working with. We'll start loading those. So we got test 20, we got train and test 20, and volume 20. We'll say train 20 file name get train 20 .csv. We'll say test and test. And we'll probably hit the end of the 25-minute period in like next minute or so. But we'll develop this until we start loading the files, and then that'll be a good time for a break. train volume 20. Make sure to change this name to test volume 20. So we'll say that train 20 is going to get read CSV. File equals something. Header equals, let's check real quick if we wrote, yeah, we wrote a header, of course. So we won't include that one. We won't include the step either unless we really need to. So we'll say we set our working directory to be data directory. And the file is train 20 file name. Let's see if that works. Looks like it worked. Double check. Our time did indeed go off, but I didn't hear it, so that's a little bizarre. All right. Double check that before we go on break and try to make sure that's all set. So we'll set up tests and then volume. Get all our data loaded up in here, and when we get back, we're gonna set up for the training, right? Something like that. So we'll get those cranking. Let's double check why I couldn't hear that in my headphones. We'll check the settings, sound test. Oh, I have the sound muted. Weird. Okay. Let's see. It's probably about to be too loud because I turned it up, but let's check. Wow, yeah. That's way too loud. Okay. Should be okay on the stream and on the video. Just my headphones were really loud. All right, we'll save that, and we'll start a short break. And I will be back. Alright, we're back. So, let's see how R did after we start another Palmo. Alright, so loaded just fine. Now let's do some head peeks real quick. So we'll look at the head of each of those 4 data sets. Okay, so we have our target 20-day returns column for train 20 and test 20. And we're going starting in 2010. I'm going to adjust the size of the console here. We'll look at the volume returns as well. So we have volume returns. You can see in the training, MLCO has a huge decrease right there in their volume. And take a look at tests. We also, we have the same value repeated in the test there. That seems likely to be some sort of error, so we want to investigate that. Oh, we see that in test 20 as well. Let's take a peek at the code real quick from back then. Maybe it'll give us a clue. So we wrote out train 20, test 20, train volume 20, and test volume 20. Okay, no problem there. Set the target column name, target 20 day. We have our data set under train 20 is train. Our data set under test 20 is test. For construct target, our train volume uses train, and our test volume uses test. That's good. So maybe it has to do with the name. Though we still should be able to train if there's some problem with test. But let's look at the tail of test. So we'll just do the tail of everything, because why not? It's quick, it's cheap, it's easy. Might as well. And we're looking a little bit at the data here. Ultimately, we're going to train and test on larger, different, well, mostly different data sets. So this isn't a big concern for data leakage, in my view. And we just have zeros on everything. So let's do a summary. We'll do a summary on target 20 day and volume 20 day. We can start figuring out what possibly went wrong here. Okay, we do have a range of values on train 20, target 20 day. Got a range as well on test. Test volume 20 day. Looks a bit wonky, so let's review our exploration here and add some notes so we don't get lost. Looks like maybe test volume wrote the actual volume? It doesn't seem right. But yeah, let's review. Ooh, okay. Okay, so we were looking at head to test volume. We start on the 10th and on the 31st we have just a repetition values on test volume. Maybe something in the loop got caught, and so it repeated a value that it had stored that we should have set up a little bit differently. And test 20 is the same problem in target 20 day. Let's observe our outputs from tail, and probably want to do some dims in a second here, and also do some graphing. See if there's any spikes anywhere. It'll make it more obvious if we got big repeats. Also do some unique value processing, counting, and see what happens there. Possibly, we'll see if we feel like we need to. So on tail, train and test, start or have a lot of zeros. That's in a same day return, so this is a processing thing we should deal with. So zeros in same day target 20 day. For train 20 and for test 20, and I think we might have the same kind of situation happening. Train volume 20 and test volume 20, but we'll just make sure for our volume 20 day. Yep. Okay. That's not, again, it's not a huge deal. Like, probably want to just throw those out anyway. But we're documenting everything so we can try to catch any problems we have, so we can do some good work here, you know. Ultimately, that's the goal. Summary test volume doesn't look like returns. Looks like raw volume instead of returns. Okay, so now we'll look at the DIMs and we'll do some further investigation. Unfortunately, you know, this is a very necessary and regular part of doing data science, is cleaning up your data. But you know, get used to it. This is how it goes. Being able to get through this stuff will get you to the fun and interesting stuff faster. Okay. Yeah, those look fine. I think all of these look good. So like what we might be looking for there is like drastically different sizes, different numbers of columns or anything like that, but the number of rows are the same for train 20 and train volume 20, as well as the test versions of that, and the columns are there's only 5 columns in each of them, and the number of rows from train to test is only different by about 100,000. Like, did I read that right? Yeah. By like 130,000 or so. So I think I want to do a length unique on the target and volume variables. See if there's any immediately, like any repeated value. So we'll say length doing length of unique. What that'll do, so the unique call will turn those values into just the unique list of values, so no repetitions that occur in that variable, and the length will tell us like how many. So how many unique values are there? We're just iterating this way because it feels more efficient to me. Length unique. So that seems pretty fine, pretty similar. Let's take a look back at the problematic head peaks. So that will be in the test data where we saw. Are those the same day? Is something I'm wondering. 12:10 to 12:31. No. 12:10 to 12:31. No. Okay. So maybe a histogram. So we'll look at histograms of the targets and the volume returns. See if that tells us anything. Oh, whoops. I forgot to do Control C. If anybody out there is watching, hello. If not, then hello to me. Let me adjust the old graph volume thing. Graph console, so it'll be a little bigger. Make sure it's visible on camera. Yep. Alright, so looking first at target 20 day. Okay, there's a lot of values around here. Sure. Test 20 day. Looks different. It might just be due to the histogram function in R, so we'll want to make sure that it's like actually different for some reason. Train volume looks really weird, although test volume looks even possibly a little bit weirder. Alright, so let's page through these again. So, train 20, target 20 day. Has a high concentration near 0. And like, I don't necessarily recommend actually looking deeply at this sort of distribution when you're doing your real training stuff, but this is pretty exploratory. We chose some really small data sets to be able to work on camera and be able to make some mistakes and not have it like leak too hard into anything. So we'll note that there's a high near 0 concentration. Let's look at test 20, target 20 day. So distributed there. That's like, so 5e to the e5, that's 50,000. That's a lot. Seems much more regular in tests, but like You know, that's not necessarily a bad thing. Like, it's a different time, so returns being distributed differently. Say again that this one has like a high concentration near zero, but it's like it's got some broad shoulders. Which I think is fine. So the volume returns, which that might not be the correct term for it, but if you do a returns calculation but you use volume instead of price, this is what we got. A very high concentration near zero. It's like it's got heavy skew. Not even like skew. Well, it is, but just peaks and drops down and looks really weird. This one is a heavier skew. So makes me wonder if there's some errors happening there. So what did we get when we did our length uniques? $3,000, 2,000, 3,000. That seems bad. So given that there's almost 1 million rows, does it make sense that there would really each value would be repeated 300 times on average? I don't think so. That seems wrong. So let's try to figure that out. I have an idea. It might be related to symbol. No. No. Okay. So, I think to work on diagnosing this, we'll go back to the constructor code we created. Try to see if there's anything wrong with that. I have my next break in a minute here. So we're doing, is it calculate return? Let's just make sure. We read in train and test. We do construct target, which we have collapsed here. Looks cool. It's that little green symbol. Okay, so what we do is we derive the unique dates. We'll come back to this. I'm gonna do 10-minute break. I'm a little frazzled. And then we'll be back. Hello, everybody. I am bringing back the webcam. Greetings to anybody who is watching. Please feel free to say hi in the Twitch chat. We are going to try to keep debugging here. So that's lots of fun. Alright, so I think we kind of want to figure out why we're getting repeating values. Like a lot of them, it seems like. Perhaps our algorithm is a little bit wonky for calculating returns, so we're going to investigate that. Let's see. Got this like fake skin bandage stuff to put on one of my new tattoos, and it's I replaced it right before the stream started because it was coming undone and exposing the tattoo, and it's like happening again already. Last time I had a tattoo in that area, that happened very quickly, so I think this might have even lasted longer so far, so that's pretty cool. But you know, just hoping it heals well. So we're looking at the construct target. Do you want to look at construct target or construct targets? So we're getting the same value by date sometimes. Construct target. Yes, okay. Just making sure. Did I start the next I did not start the next Pomodoro yet. Okay, there we go. So our construct target receives a data set, data column name, default to be called date formatted, a constructor column name, number of days return to calculate, and a target column name for the target that we will derive. So if I remember correctly, calculating each of these took about an hour. So we'll have to work around that because that might be some off-stream work if I have to rerun these. But we start by getting the unique dates in the data set, and then we sort them, and then we instantiate empty vectors, return sub, date start sub, date end sub, symbol sub. DF target. And after we read through this, by the way, like we won't like try to get abstract about it for too long. We'll just start testing it with the first like rows of data that we can, or whatever, and debug that way. It's usually a lot more effective. Accidentally closed the Rocket chat, so I'm gonna open that back up. Alright, so we set the names of our empty data frame here, symbol, date start, date end, and our target column name. And then We loop over the unique date backwards. Then that's date's unique sorted. So we get date sub index. It's going to be which data set date is less than or equal to date sub. The data set sub, we just, make a subset based on that index. And we create a data frame of the start and end called df start end sub. We're doing derive start end for target. Data set equals data set sub. Days return target gets days return, and the date column name because date column name. Calculate the return. So we calculate what the height is, and then I'm feeling like doing the actual values is probably gonna go faster and better. We use a function we made called calculate return, passing date starting and date ending, and return sub gets incremented. Date start sub, date end sub gets incremented. Symbol sub gets incremented. We build a target with those. Alright, yeah, let's just load our training data and start stepping through this just little tiny bit by bit. We're gonna go up to the top, find the part where we loaded training data. So, we have a price volume. Is that what we need? Where do these come in? We remove the NAs. Okay. Alright, so we'll step through this. Read price volume. It's going to take us 2 or 3 minutes. While we're waiting for that, go grab something real quick. Okay, sorry about that. Oh, look, our price volume already read in. Awesome. So, we want to that's just investigating NA dates. We want to remove them. So we'll run through this. So we're just doing some cleanup here. And then we're removing NAs by column. Okay, so we have train, test. Alright, great. We already... Okay, so now we want to walk through our functions. So let's just define those real quick. And then... Alright, so we're gonna investigate train 20, and the way we'll do this is we'll make variables with the names that we're going to pass to the function construct target, and then we'll walk through the construct target function line by line instead of just running the whole thing, and hopefully that'll make it obvious where these repetitions are coming from. But actually that might not be with this data set, so let me just check our notes. And this is why you take notes. Where did we get the repeated values? In tests. Okay, so we'll do it for test. Well, let's say, alright, the only difference is that data set equals test, so we'll redefine that. Ooh, it's misaligned. I hate that. See if I remember to update these files. They're not like ultimately going to be the most important output, so it doesn't matter that much. But construct target. I want my soda now. So given that running R and OBS at the same time, running RStudio and OBS makes my computer pretty hot, I found a way to cool it down just a little bit. Maybe, I don't know if it actually works, but it involves Mountain Dew, and do not try this at home. Okay, we are in construct target, so we want to look at dates unique, or we want to get dates unique. We want to get dates unique sorted also. Let's look at the head of dates unique sorted. So it starts in 2008. We'll look at the tail of dates unique sorted. And we're going from January 1st, 2008 to December 31st, 2010. That's all well and good so far, I think. So now we want to declare these empty variables, declare this empty data frame, assign the names, and let's say, so this is how I step through these. I'm going to say that date sub gets the first value in that. So date sub gets rev dates unique sorted 1. Let's look at date sub. So we're going backwards, starting with 2010, December 31st. Okay. This is pretty weird. I guess I wrote it, but it made sense to me at the time. So let's see. So we got our date sub. So we want date sub index. Bunch of numbers. Which dates, so it's a data set of which dates are less than or equal to date sub. And it seems like it's all of them. Makes sense, because this, we sorted it and then we reversed it. But, you know, is this truly the order we want to be going in? So that's a question to me. Then we want to subset the data set. It just gives us the same one, honestly. And we figure out the df start end sub. Which is starting and ending date indices. For dates, yeah. So we're walking backwards. We want to know what's the 20-day return on date sub, which is December 31st, 2010. So we want to get those 20-day returns. Fine, great. We've got it. So we want to calculate height df sub. 1427. Set up return sub, date start sub, date end sub, symbol sub. Okay. And we haven't jumped in, we haven't executed inside of this nested for loop here at line 300, but we're gonna just take a look at it real quick to try to get an idea of what's happening. So we're calculating the return, calculating the date start, the date end. That seems fine and good. Let's just run that whole thing. We'll come back to it if that's where our problem is. I'll probably do a bit of debugging this week. We'll see how bogged up it gets. So df target sub then gets built up. And return sub gets return row. Let's look at df target sub. Yeah, lots of repeated values. Okay. Something's wrong there. Let's just assign the names how we like it. And we won't build df target just yet. Let's look at the next few rows of df target sub. So df target sub. We'll index into it. Make sure we have that colon. So that's just like omitting the first 250, then we'll omit the first 500, then we'll omit the first, are they all the same? I'll omit the first 750, we'll omit the first 1000. It's looking like they're probably all the same. We'll omit the first 1250. Okay, we've got LYB is different there. That's this is peculiar. Let's take a closer look here. Okay, so 097154533. That seems to be a very common value here. Stuff is changing at the end, at least. Oh, but this 097154533 is quite common. Oh, and I see 2010, and then we have 2008, and it's peculiar. Still a 20-day. But that shouldn't be there. All right. So we have occasional changing values, but a lot of the same. How? How did we get it? Let's go up even more. Oh, and it changes when that date changes? Is that right? Okay, I don't have anything above that. Okay, that's a different date. Different date. Different date. Different date. Okay, so we're getting a value repeated somehow by the date. I wonder if our data set's bigger than it's supposed to be because of that. It might be the case. So, where is our... It's changing like the year by the year. Okay. With a different year. So let's go back to this line 300 nested for loop. And we'll play around in that a little bit. And then we get to do some more debugging. Hooray. So we'll say index row gets seek height 1. That's our cue for another break, but let's poke around with this a little bit more, and then we'll take a break. So row sub, date starting, ending, value ending, return row. Let's see what return row is. 0.09715453. So our error might be in calculate return. So we have date ending, or date starting, date ending, value starting, value ending, and days return. So let's see what all of those are. Date starting. Yeah. Yeah. Value starting is 4599573. Value ending is that. Days return is 20. Okay. So, this is where we should be getting a value. But why does it return the same value based on the date? Is it only going based on the date? That doesn't make sense, right? So we'll probably have to look at this function, but let's play around in this space a little bit more. So index row should be 1. Let's just double check. And then we'll assign it 2. And let's say that we'll set a variable called preserve. It's gonna get date starting before we step through it on the next one, so we can start figuring out, are we getting the same values? Like value starting, value ending is what I'm really interested in here. If those are the same, then we have to look at the data set and say, does the data set say these values are the same on these days for these different symbols? Because that would be quite strange and indicate some more debugging that I need to do. So, days return. Origin must be supplied. What? Which of these doesn't like that? Let's try to call it a data frame instead then. See if it allows that. Let's look at preserve. Okay. Cool. And we'll say P1 gets preserved. Now we know index row is equal to 2, but we'll just make sure real quick. It's 2. Yeah, good. We'll set that. Then we'll set preserve that and say P2 gets preserved. And let's look at P1 and then P2. It's getting the same values. That is really weird for value starting and value ending. So that's row sub by index of df. Let's look at the head of df start end sub. Df start end sub. Let's okay. Alright. I think our indexing is erroneous is probably the problem here. So we're pulling row sub date start index, which gives us another row date start index. But that's not the row we should be getting. Should that be dataset sub? From dataset sub? No, that should be something else probably. It's time for a break. Okay. So we'll come back and we'll start figuring out what's up with that erroneous indexing. It's exciting. I'm excited to actually figure this out. Let's do a short break. Alright, I am back. So, let's investigate this error a bit more. So we're getting the date starting, date ending. That's fine. We want to also get value starting. We want to get value starting and value ending correctly. So, how can we do that? I'm gonna check something real quick. So, what was it called? DF sub? DF target sub. Let's say 4Ds gets DF target sub rows 1 to 5. And we'll R-bind it with itself. So I want to look at quad D, and does a unique call just give us the unique rows? Because that might be relevant later. It does. Excellent. Okay. So as we index through here, we get row sub. Let's look at the head of dataset sub. I'm going to say value starting is going to be the row for which wait, let's look at row sub. I'm just trying to figure out exactly what we're doing here. Okay, so and we'll look at that. Okay. Got it. Date start and date end index. What even? So we need to investigate that too. But we're getting closer. Have no fear. So that's DF start and sub. So we want the starting date. We want the ending date. Date start index. Okay, so we'll start by investigating that. DF start end sub. So where does that get defined? Derive start end for target. So let's look at that and then we'll come back around line 300. Derive start end for target. We'll expand that. Okay. So that function gets passed a data set, the day's return target, and the date column name. So how does start index and end index ultimately get derived? Index first, index last. Looks like we're just doing an incrementing algorithm there. Okay. Starting with negative 999. Index last gets date length. And date length gets length of symbol data. The date column name. What is symbol data? Symbol data is data set for which the symbol is equal to the symbol in that. So I think we're not like subsetting by symbol, although at that point perhaps we should be. So let's get back into it over there. So alright, what am I doing? So I am trying to debug this issue, trying to see like We should be subsetting by symbol in some way, but we're not. So why aren't we doing that? Let's figure that out. We're around row 3, line 300. So we have index row, a height of df sub. So what is df sub? Let's back it up a little bit. Is the height of df start end sub. So we give it data set. We give it days return. We give it column name. So we say row sub. We say derive start end for target, which for each of those is going to give us indices based on that data set, but only for going to give us that data set. But the indices are only going to be for a theoretical subset of that data. Based on the symbol from each row. Okay. So we could probably still work with that. That seems like it might be fine. So we get row sub, which, as we can see down here, gives us the symbol, date start index, data index, and then index, and that's for the subset of that data frame that it's coming from, the subset where the symbol is equal to SIMO, in that case, SIMO. So that's what row sub is. So if we're using row sub, we need to maybe we need to make our own symbol subset for that symbol. So height df sub, some df start end sub. So let's just check height df sub, and let's check the length of the unique symbols of df start end sub. Oh, whoops. Of the symbols column. Same as the height, so that's good. So let's make a dataset symbol sub. And after we've done some poking around, like let's poke around a bit more with this, but let's call it a half stream and do another 2-hour one to finish the third of the 4-hour streams at another day. Because I don't feel we have enough time to like plan stuff out that much, and I'm clearly losing steam a little bit, so I want to make sure everyone gets their money's worth. Which for most people this will be free, but in any case, I want to make sure I'm doing good work, starting to become a struggle, so I don't want to keep on for too long after this. So we'll delete this, and then we'll make a dataset symbol sub. So we'll say dataset symbol sub is gonna get dataset sub indexed by which dataset sub symbol is equal to row sub symbols, and we'll pull that out and make it a variable so it's more readable. We'll call it index symbol subset. Symbol subset index symbol subset. Yes, that. Dataset symbol sub. So now that's making some more sense. I think, at least. But we should delve a bit deeper. So we'll probably, calling this a half stream, we'll probably do actually about 3 hours total. And then maybe we'll do 2 or 3 on the second half. So we'll throw some extra hours in there. So since we have dataset symbol sub, that's what we want to get our date starting, our date ending, our value starting, our value ending from. And I think we want to redefine the functions now that we've rewritten them. And I should, so we'll redefine the functions now that we've rewritten them. And then we'll check those outputs we were looking at before. This indexing should no longer be erroneous. And so we've saved it. We've done that. Let's run it and take a look. Let's collapse our functions again. Okay, so we have redefined those. So we know these take like an hour. But is that what I want to do? What was do we have a faster checking method? Okay. We don't. So that would be a good place to call it. I started at 10:15. We've gone more than 2 hours. So we'll call it there, and I will start testing these functions again. And I'll just do one at a time, but I'll do some debugging off camera and then try to come back on Monday with another half stream. cheers, everybody. If you checked it out, thank you. If this was helpful to you, please let me know. Twitter would be a good place to reach me. Anyway, thanks a lot for stopping by. Hope everybody has a good week ahead.